Hello, David here. Today I'm going to show you how I designed and printed these wheels that I use on the slow sticks. These are new ones. They're 91 millimeters in diameter, and this time I wanted to try some PETG, but I've been very happy with them in PLA, so you can print them in either one. They're very durable, pretty light. So stick around as I show you through the steps in Tinkercad. Okay, starting from Tinkercad.com, we can go in and do some design work. This is in no way sponsored by Tinkercad. It's just simply one of the tools that I really enjoy using in development for a lot of the 3D printed parts. It's very quickly. I can do up shapes and 3D print them from the STL files that are generated here. And so today we're going to go under your designs, but we're going to create a new 3D design. And we will create a wheel and a tire that can be printed and used on an RC airplane. I'm going to assume that you're fairly familiar with some of the locations of most of the stuff, and sorry if I jump to conclusions that you may already know. However, you can spend a little bit of time in here and get to know the shapes and what they are and what they do and some of their configurations. So right here you start off with the basic shapes, and these have most of the shapes that you're going to use, and the basic concept in Tinkercad is you create a shape and you can add and subtract from it. So one of the first things we're going to do to create this wheel, we're going to start with a cylinder. I'm going to smooth out the cylinder by increasing the number of sides to the max. And then the other item I'm going to do is I'm going to add a little bevel to the top of the hub. Maybe we'll just type in here, make it 2. And let's go ahead and make this hub maybe 12 millimeter by 12 millimeter. That'll give us a 12 millimeter hub. That bevels it also on the bottom. And I don't want the bevel to be on the back side, and I also don't want it to be this high. We're going to cut that bottom part off above. So this little cone icon, and if you notice, we know that the part is 20 millimeters high, so if I put 10 millimeters below the floor, we'll use that as a guide to cut. And to cut that bottom part off now, I'm going to take the subtraction cube, I'm going to lower it below 20 millimeters, it's below the floor right there. And I can just set this underneath, and you notice that it encapsulates the entire bottom part of that. And to cut that off now, I'm just going to highlight both of those parts, and you'll see right here shapes, there's a number 2 up here selected, and then I can do a join or group, and that's going to subtract the clear part from the solid part. So there's our hub. We need now add an axle hole, and often I've learned that in the design I want to do, if I want a 3 millimeter axle, I need to add a 0.2 millimeter kerf or space to allow the axle to pass through. Otherwise they will just be too tight. So I'm going to do 3.2 millimeter, and we need to also do the other side. And we can increase the sides as well to make it more round. Okay, at this point, one of the difficult parts in the design process is how do I make sure that I get this axle dead center. I can try to guess and move it around and spend a lot of time and try to do some math. But let me just show you, this saved me a lot of time and a lot of headache. Is you simply just highlight, select the parts that you want to align with each other, and you notice here you've got two shapes selected. This right here is the align tool. So I'm going to select it, and it's automatically going to give us some indicators of what and how we can align this. And you can just start aligning it right now. However, I want this piece to stay stationary, and there's usually times where you don't want one piece to move or the other piece to move. Now I can align in this axis, X and Y, and you can also align in the Z axis as well. So now if we look at this, we've got that axle hole perfectly centered. I'm going to leave them like this, but they are aligned. Now the next thing I would do is let's add some spokes to this, and there's several ways you can pick from your shapes over here. You can get creative. And so from here, well, I just dragged out a cube, and these cubes default to 20 by 20 by 20. But we're going to go, let's make it 0.8 millimeters wide. That's on my printer. 0.8 would give you 2 passes. That's 2 wall thick. We know that the hub is 1 centimeter high, 10 millimeters. So let's adjust the spokes to be about that same. Let's do the length of it, 35. Some of this will get trimmed, and that's fine. So I'm going to lay this in here, and it's off-centered. We'll go over that a little bit, but you'll see why in a second. So one of the things I pay attention to is that all the corners are dug in. There's nothing poking out in the bevel. That looks pretty good, and so that's great. One of the other tools here, so I've created one spoke. Up here on the left, there's a duplicate or repeat, and so I'm going to duplicate another spoke, and it lays it immediately over it, and it highlights it, and it's ready to move. And I'm going to just go ahead and rotate this. Let's go rotate it. I think the corners are each in. Okay. So there we go. We got the spokes. Now we need to duplicate these. And what I typically do is I highlight each one. I'm holding down Shift, and I'm clicking on each one. So now we know we have 2 shapes selected. At this point, you can group them, and we're going to duplicate it. So it made a duplicate of those 2 together. Now let's rotate them 180 degrees. So that's 180. And I'm going to move them up to the other side, and we can just kind of visually get them close to where we want them. Let's group these first, and then we'll align them. And you'll see why this doesn't have to be exact here in a minute. So we've grouped just the spokes, the red parts. Now they've become one part. Now we've got 2 parts selected because I just selected the hub. And then I'm going to align all of those centered based on the hub. We'll center it this way and center it X and Y. So now they should be equal to each other on each side. We want to just select those hubs again, and we're going to repeat these around in the circle. And if we don't move them and slide them around, they should just rotate in place. So I've duplicated, and now I'm going to rotate the part that I just duplicated. Let's do it 20, let's do 45 degrees. Okay, there we go. 45 degrees. Let's select these 2 parts now and replicate them. We've got 2 now, and then I'm going to rotate 45 degrees right there. Everything now is radiating and they should be identical. So the hub is not selected, but I'm going to go ahead and group those. So all the red parts now are one part. What I would do here, let's go ahead and add the taper that's going to go out to the rim. I'm going to use a cone. We're going to create a negative of what we want. So as we have this highlighted, let's do the bottom 35, 36. In the top, we know that hub at the top was, I think, a 12 millimeter. And then we'll increase the number of sides to make it smooth as possible. Let's do 5 millimeters. So we just created a cone, and you'll see in a minute, but it's going to be the negative. I'm going to put a square here, and this will make sense in a minute. We're going to make a piece that's going to carve the spokes. It needs to be larger than the spokes. So if we do 80 by 80, we can leave the height alone. And let's put this directly. We're going to make this transparent, and let's group it with the big square that we just made, and we're going to subtract it from the large square. So we should have two things selected. We're going to group, align those so it's dead center of this square one. So now we have subtracted that cone. We've subtracted that cone from this big square, and now we can use that to taper the spokes. I know this seems a little weird, but now we've made that transparent, but it still has the cone in there. And let's raise this off the ground 5 millimeters. Now we're going to use this just to only taper the red parts, the spokes, and not the hub. We want the hub to stay the same. So I've highlighted both parts. We have two parts selected. That's the spokes and the subtraction that we're going to do for the taper. And we're going to align those, and we're going to align them to the spokes. Okay. These dark areas, you can see that's where it's going to subtract. And we could probably subtract a little bit more. It's not even subtracting up here near the center. And we'll do that by go ahead and just selecting the one part, which is the subtraction part. And let's lower that down on, we lowered it 1 millimeter, and look, and it's covering all of that. So it's going to taper it down like that. So let's go ahead and we can select the two parts and group those. So in here you'll see there's a lot of other generated shapes and things that get you started. There's design starters. So if you go into the design starters and just do a search for, I think it's wheel or tire, there's somebody's created you can star and favorite some of these so they show up in your favorite list. I like this one right here because it's pretty easy to use, and you can define a lot of characteristics you want right over here. We know we want the inner part of that hub to probably be, what's the diameter across? Let's do 70. And let's move it over here. Give us an idea. So we'll center that in a minute. The thickness of this, let's 10 millimeter, same size of the hub. And then the height, we'll do the same. 10. And the radius, edge radius, if we take this to a 5, it'll make it completely round on the inside. So we can try that. So you have the rim selected, and then select the spokes, and we're going to center them on those each other. It's important that you don't move all the other parts either. The center hub, so that everything stays in alignment. Okay, those should be in alignment. Now we want to check the bottom, make sure everything digs into the... See, and that one does not. So what we need to do is we'll make that radius a little smaller, or the diameter of the tire. Let's take the whole diameter to 65 and see what that does for us. You shouldn't have to recenter on changing the parts on those tires. So we see it go in completely there and completely there. And it's okay if they go a little bit further in. I'll show you why, because when we do the final join, it'll take care of that. So we're going to replicate the rim, that shape, and let's make it a different color so that we can differentiate the two. I'm going to go ahead and make the tire this gray here. Now let's modify the gray part. If we want the rim to have a little bit of thickness, maybe 2 to 3 millimeters on the inside of that rim, we need to add double that. So we're going to take it up to 71 millimeters on that diameter, and you'll see here why. Okay, so that's the tire. And one of the things I like is if we can get this tire to hang over the rim about 1 millimeter on the inside and the outside, that would be great. So that means if we have a 10 millimeter tire, let's take it to 12, and then we're going to drop it 1 millimeter. We're going to make a tire, and then we're going to subtract it from this rim. And I'm going to lower it 1 millimeter. That'll put 1 millimeter above the rim and 1 millimeter below it. And we're just doing that for the subtraction purpose right here. Okay, 1 millimeter drop. At this point, we want to duplicate this tire and save a copy of it that's going to be the real tire. So I hit the replicate, and I'm just going to drag the duplicate off. Now we need to subtract this from the rim. So at this point, we have all the parts and everything we need. We should just be able to drag over the whole thing, highlight it. Don't get the tire in this, but we should have all the parts. And this is 5 shapes, and we'll go ahead and group them. And this is going to make our rim. And at this point, the rim should be ready to 3D print. I know it looks delicate, but it keeps it light, and I like a little bit of visibility through the tire, through the rims when I'm flying FPV. Now we need to remember the tire that we saved off. Let's go ahead and raise it up so it's not below deck 1 millimeter, it's on the deck. And now, one of the things I think is kind of important is to add that kerf, because if you print this in TPU and it's exactly the same size of the rim, it's going to be really hard to get on sometimes. It's okay if it's snug and there is some stretch in the TPU, but if we go 71.2 millimeters added to that, the inner diameter of that tire, when we go to print that TPU, it's just going to have a little bit more ability to get over the rim to fit it on. At this point, we should be ready to 3D print these and give them a go. So part of what we need to do before we print it is export it. If you're new to this, is you can just highlight the part, and I like to do the individual parts because you'll need to lay them out separately to slice them for the material you plan to print them in. Hit export, so we have the rim highlighted. We clicked export, and we're going to save it as an STL. And do the same thing for the tire. In preparing these files to print, I use Prusa Slicer, but you can use Cura or anything you're comfortable with doing, and I'll try to make the descriptions as generic as possible. But let's prepare the wheels first. So I drag one in there. We'll take a look at it, and that seems to look okay. I think these are going to be thick enough. So from here, let's go ahead and duplicate that on the bed. We've got them laid out. The infill is not a big deal here because the only part that's really going to get any infill is the hub. You can do 30 or 40. What I do is I often put the perimeters. This is the number of layers that are around the outside edge and the perimeter. I bump that to 3. Prusa likes to default to 2. I also bump in the solid layers on the top and the bottom a little bit. And then we'll go ahead and select the Prusa PTEG, which I'm using, Prusa Mint. And let's go ahead and slice this and see what it gives us. And we'll look at the layers real quick. Okay. So, wow, that's going to be some thin. Yeah, we got two layers per spoke, which is pretty thin, but they're going to be light. But those shapes and those triangles, they really are pretty strong, and it'll be interesting to see. So we can look down the layers. We can see what it'll look like as we go down. The hub will have some infill in it. And there's the bottom. So that's the first layer. It gets 2 layers around on the base, and then it builds it up. Let's go ahead and export this to the G code. Just put it somewhere. I'm just going to put it on my desktop. So I throw a tire on here. Okay, let's copy that and duplicate so we can get 2 of them. And let's just arrange them on here. Probably about in the same way. When you're printing the tire, you want to use the flexible filament. For my printer and the material that I use, the Sane Smart TPU profile is probably the best right now for me. So I'll select that. We also want to put the infill to 0. These are going to be hollow tires. They're a real tire. And the number of perimeter walls, let's bump that down to 2. That'll make them nice and flexible and light. And we're going to bump down the top layer count to 3, and the bottom layer count also to 3. So here we can see you get probably 3 layers at the top and then 2 layer walls, and they're hollow. And the printer does this just fine. There's no problem with it. It can build these walls, and it comes down, and then what gets laid on the first layer looks like it's 3 or 4 lines. Let's go ahead and export that. And that's for Flex Filament TPU, and we'll go ahead and put that on the desktop as well. From there, just take them to your SD card or to your Octoprint and print them separately for each of the filaments, and we'll go from there.